So we're looking at first year maths here. It's Geometry 1, part 5, and we're looking at drawing parallel and perpendicular lines. Now on this I don't have a protractor or compass or a ruler or anything, so I'm going to also link some videos in the description on actually how to do them as well, so they're probably worth looking at, this video and the other video. So if you're given a line and a point A like this, so you're given a line here and you're given a point A, and you want to draw a line that is parallel to this line but also goes through A, what you do is you set your set square parallel to the line that you want to draw parallel to. Then you put your ruler perpendicular to it and then slide your set square. So move it slowly from this position. You slide it along. You slide it along until it's containing the line A, and you draw in your parallel line then through the line A. We've already met perpendicular lines. We know that the line L and M are perpendicular if we have this symbol here, or the symbol could be drawn in like that. And we know they're vertically opposite as well, because there were two lines that are straight across each other. So this angle must equal to this angle, and this angle must equal to this angle. Perpendicular lines can be written like that, that L is perpendicular to M. If you want to draw a line that is perpendicular to this line, but contains the point P, you'd need to line your ruler up with the given line and use your set square to slide it. You can put your set square against your ruler and you can slide it along until it contains the point P, and then draw in this line L, which would be perpendicular. Also useful to draw in the fact that it's perpendicular. So just talking to you a few example questions then. So what's the size of angle C? You can see that the angle C is 90 degrees. So 90 degrees. Name the side that is perpendicular to BC. So BC is here. What's perpendicular to it would be AC. What about the likes of this when we're looking at a three-dimensional situation? The diagram shows a rectangular box. Name two edges parallel to AB. Well, where's AB? AB is here. Two edges that are parallel to it. We could say DC, we could say HG, and we could say EF. So any of those answers. So 1, DC, HG, or EF, and they're line segments, so we're putting our square brackets around them. They have starts and ends. Name two edges that are perpendicular to HG. Well, where's HG? HG is here. Perpendicular to HG is going to be going straight up, so we could say DH or CG. DH, CG, and our square brackets. Part 3. How many edges are parallel to DH? So DH is here. How many edges? So 1, 2, and 3. 3. And name three edges that are perpendicular to BF. So BF is here. Perpendicular to BF could be this one, this one, this one, or this one. So what's that? AB, BC, EF, or FG. What about here then? The diagram shows the shape ABCDE, so five-sided shape. Name two right angles. Well, we can see that the angles D and C are right angle because the symbols are there. The angle D, the angle C. What line is perpendicular to BC? So remember, perpendicular to BC is going to be at a right angle, so DC, DC. 3. Name an acute angle. Acute means small, doesn't it? Smaller than 90 degrees. So we're looking up here. We could say it's the angle A, or It's the angle EAB. So either way you want to describe it, EAB. An obtuse angle, okay, an angle that's bigger than 90 degrees, so IV. There's two options. We could either say the angle E, which could also be described as the angle DEA, or we could use the angle B, which could be described as ABC. B, the angle B, which could also be called ABC. And name two parallel lines. Hey, it doesn't actually say in the diagram that they're parallel, but I know they're parallel because there's two 90-degree angles between them. Imagine if you're walking along this road, you turn right, and then you turn right again. Maybe in New York, you're walking along the straight avenues, and you take a turn up a street, and then you turn right again. You're going to be on another avenue. So, yeah, it's absolutely going to be BC or ED. If you haven't been to New York, maybe look at Google Maps and you'll see that all the avenues are in straight lines and there's a real grid system to it and they're all parallel. And the last question for this video, using the information in the diagram, write down an equation in terms of y. So an equation with y in it is really what in terms of. So I know the size of this angle is 180 degrees. So I know 4y plus 5y is equal to 180 degrees. Does it ask me to solve it for y? No, it doesn't ask me to solve it for y. Part 2, I know an equation in terms of x. I know that this is 180 degrees there. So this is 90 degrees. 90 plus x is equal to 180 degrees. And how do I know they're 180 degrees? Because they're straight angles. Using the equation in part 1 and part 2, find the values for x and y. 9y is equal to 180. 4y plus 5y is 9y. I want to get y on its own, so it's divide by 9. Divide both sides by 9. Y is equal to 20 degrees. What about over here? X is equal to, going to subtract 90 from both sides. So it's 90 minus 90 is equal to 180 minus 90. X is equal to 90 degrees. Done. Hopefully you found the video useful.